When an intricate glass object shatters, we immediately recognize the direction of the event. Our reality follows a strict one-way path from order to fragmentation. This experience vanishes at the microscopic scale. The equations governing the smallest particles in the universe lack a preferred direction for time. These collisions are time-symmetric. The math remains valid whether the particles move toward each other or rebound away. For a single atom, the distinction between past and future is mathematically irrelevant. This creates a structural conflict. If the building blocks of existence are indifferent to time's direction, some other mechanism must be managing the universe's one-way ledger. Standard physics resolves this paradox through the second law of thermodynamics. The concept of entropy is often mischaracterized as mere mess or chaos. Entropy provides a specific count of microstates. This visualization shows how many different microscopic arrangements can produce the same macroscopic state. Isolated systems move toward more probable macrostates by statistical necessity. Heat and information disperse because high-probability configurations mathematically overwhelm the rare, low-probability ones. The second law makes macroscopic reversal practically impossible, turning time into a statistical certainty. However, relying on statistics alone leaves a gap. We need to identify the geometric mechanism that actually enforces these probabilities. General Emergence Mechanics approaches this from a different layer. This is a geometric question beneath thermodynamics, rather than a replacement for it. This framework focuses on how the geometry of reality makes permanent structural commitments. Reality constantly tests various geometric routes, seeking paths that can successfully close into a stable loop. When a route successfully closes, it leaves a permanent structural trace. It solidifies into a fixed part of the network. This trace changes the admissibility of future paths. Reality has paid for this specific geometry, forcing subsequent routes to originate from this new strut. This locking of permanent traces creates irreversibility. The universe cannot return to previous states because the geometric constraints have physically changed. To understand the arrow of time, we must look at the routes that failed to lock into place. Within this framework, entropy is the residue of discarded alternatives. It represents the loss of geometric precision when a path fails to close. Entropy is what remains when reality refuses to pay for impossible geometries. Entropy serves as the physical graveyard of impossible choices. This shifts our understanding of time itself, moving away from conventional metaphors of flow. As we've seen, time is not the river. Time is the wake left by routes that were allowed to persist. The arrow of time is an emergent consequence of these irreversible commitments, not a fundamental command or an external force. Time is not the driver. Time is the footprint. The arrow writes itself. In this framework, time is geometry remembering entropy. Thermodynamics manages the probabilities of what might happen, but geometry maintains the ledger of what actually occurred. The universe does not have a built-in clock. It has a built-in accountant. If you want the written foundations behind this series, the books, papers, and playlists are linked below. The videos are the gateway. The books and papers are the foundation layer.